Okay, we're here today to take a look at my next Arduino project. It's again pretty basic. Essentially, what we've got is an RGB LED. Now this is a common anode LED, so it uses 4 pins on the Arduino, well 3 pins on the power supply. There's one pin that goes to each of the channels, the RG and the B channel of the LED, and these are controlled using pulse width modulation (PWM) from digital outputs on the Arduino. You can see there we're using 5, 6, and 7. And then they obviously go through current limiting resistors to drive the LED, the channels of the LED. And finally we have the common anode that's essentially tied through that long wire, and I didn't have the appropriate color wires, so I've used a green wire, but actually that goes to the positive 5 volts, as you can see. Now it's interesting to note that this is a common anode LED. Of course you get common anode and common cathode LEDs. What this means is that by default, if the pins, the digital pins are low, then the LED is going to be driven, or it's going to glow. So what we need to do is we need to remember that in its initial state we need to make sure that the RGB channel digital pins are held high, and of course the anode is also held high at 5 volts, and as a consequence obviously the LED won't glow. And as using PWM duty cycles, we reduce or we increase the duty cycles and tie these pins to ground or low. That's the point at which the LED starts glowing. Okay, to do that, or to control the digital channels, the digital PWM channels, what I've got here are 3 10K potentiometers. I've got these really cool ones that actually, I don't know if you can see, but they mount directly, or they plug directly into the breadboard. That's super convenient, obviously making it so much easier to sort of wire up. And for some reason they actually came with these little plastic knobs that you see here, which are really neat as well, and make it look a little bit more professional, dare I say. In any case, obviously each of the potentiometers has three inputs. There's the 5 volts and the ground, of course, at either end of the potentiometer. I don't know if you can see these 3 inputs right here. So the leftmost one that you see is obviously goes to the ground, and the rightmost one goes to 5 volts, and the center one is the one for the wiper, which is actually tied to the analog input, and that's the analog input signal. And obviously what happens is, as we rotate this wiper, the resistance on the wiper pin changes, and so the voltage flowing into the input analog input changes. So at its leftmost position, it's tied to the ground, and so it's 0 volts. And as we rotate this, it goes up through in an analog fashion, of course, right all the way to 5 volts at this end. And that's obviously the voltage on the wiper pin, keep in mind. And so obviously there's a little bit of tangle of wires here. What I've done is I've obviously just tied together all the grounds and all the 5 volts. And at the end of the day, if you look closely here at the analog pins, you should be able to see, let me just get this out of the way, you should be able to see the 3 signal wires that are going in there right at the end. So there's a blue wire, an orange wire, and a white wire. Anyway, that's pretty much about the circuit. What I'm going to try and do is I'm going to just show you how we cycle through the different colors on the LED. It's also obviously active and on. The wipers are all set to 0, so the LED isn't glowing at all. Now, of course, you know, or you should know, well, it doesn't matter if you don't, that there's 8 bits of sensitivity on each of the digital PWM channels reading out. So that's values of 0 to 255. So 0 to 255 thresholds, or levels of brightness, if that makes any sense, for the red channel, the green channel, and the blue channel, which is 8 bits. So it gives you 8 bits per channel times 3 channels. That's a total resolution of 24 bits, which in theory would give you something like 16.4 million different possible colors on the LED. Of course, in practice, it's a little bit difficult to discern that kind of resolution. So, you know, if a red value is changing, say, from 10 to 11, a single step, it's going to be practically impossible to really tell. But there is a fair degree of sensitivity. I'm not sure how great the camera is going to be, but we'll try and do this. I'll just show you the 3 pure channels. So let's start with the red channel, and you can see sort of the brightness of the LED increasing, if that makes sense. There we go. I should be turning the red channel off now, and then we see the green channel, and that's as bright as it goes. And then we see the blue channel. Of course, you do realize that to light the LED, what I'm doing is I'm just turning the potentiometer connected to the associated channel. Now, of course, you know, that's very nice, but pretty trivial. And of course, really, the fun starts when you start mixing the colors. So let's say we've got a little bit of red here on the red channel, and then we mix a little bit of blue. Theoretically, we should get sort of a purple color. And then, of course, we can increase the red a little bit to get a more magenta-ish kind of hue, and so on and so forth. And that gets quite interesting. So that's just pure blue now. And of course, I'm adding some green now to make it sort of a cyan kind of a color. And as I push the green up, obviously, I think it's a little bit hard to see on the camera. And of course, the last thing that's worth showing you is if additively, if you sort of increase the brightness on all the channels, or the voltage on all the channels, you get a very bright white light, which is obviously a mixture of all 3 channels. And of course, you can keep sort of cycling through various different colors. For example, this is sort of a yellowish kind of color with red and green. As you increase the degree of green in the color, it starts moving towards the orange end of the spectrum. It's quite interesting. It's a particularly nice color. And of course, it's fully red now. Well, you can sort of see perhaps more by the reflection on the breadboard. Anyway, that's a pretty simple project. It's just fun to do, get accustomed again to the PWM code, get used to working with the analog inputs and the potentiometers, and just a little bit of wiring. Hopefully we'll try and take this project a little bit further and do something interesting with perhaps the way that we actually control the LED itself. Anyway, that's pretty much all for now. Yeah, I hope you enjoyed that. If you have any questions, obviously, just post any comments on the blog, and I'll be happy to try and answer them. All right, enjoy.